Okay, chemistry 1.1.5, Explorer 5. How can two objects of different masses have the same temperature but different amounts of thermal energy? Okay, what do you know? Pause the video, write down a few ideas about what you know. Okay, so a quick review here. Temperature. It is the average kinetic energy of an object, right? We've talked about this before. Differences in the number of particles in a given object can result in them having different amounts of thermal energy. Okay, differences in the number of particles in a given object can result in them having different amounts of thermal energy. Remember our example of the bucket A versus bucket B. One was fresh water and one was salt water. The salt water had more particles. It had a higher number of particles, and so that resulted in having more thermal energy. Well, in essence, we could say that salt water was denser, right? And that's the same thing for any object. You know, woods have different densities. Some aren't very heavy and some are very heavy. Metals have different densities. Aluminum is not very dense, but iron is, right? Okay, letter B. A material's ability to absorb and release thermal energy varies from other materials. Okay, that's true. A material's ability to absorb and release thermal energy varies from other materials. And that brings us to the term specific heat. This is the amount of energy required to change the temperature of 1 gram of a given substance by 1 degree Celsius. This is specific heat. So it stands to reason then that if different objects have different rates that they absorb and release thermal energy, then they're going to have different specific heats, right? Aluminum is going to have a specific heat that is different from copper, right? And simply, I mean, it's really kind of a continuum here. You can see this long line down here. On one end, we say you can have low specific heats, and over on the right-hand side, you can have high specific heats. If you have a high specific heat, it's going to take a lot of energy to change your temperature. Okay? If you have a low specific heat, it's going to take very little energy to change your temperature. Okay? And an example that we had discussed was copper versus aluminum. Copper has a low specific heat. It takes very little energy to change the temperature, right? And that's because the density, it's a heavy metal. When you lift up copper, it's like, ooh, that's heavy, right? But aluminum, on the other hand, there's a little more space between the atoms. It takes a lot of energy because this has a high specific heat, okay? And specific heat, what are the units that we measure those in? Joules per gram times Kelvin, or kilojoules per kilogram times Kelvin. Okay, so here you're kind of seeing we're using Kelvin there. You can express this as joules per gram or kilojoules per kilogram. Alrighty, let's take a moment just to summarize what you learned, and we'll talk to you soon.